We're going to continue on in our 7th, 8th grade geometry unit, and today we're going to talk about volume again, but this time we're going to talk about figures that you should have learned in 7th grade. So in this case, we're going to talk about the volume of prisms and pyramids. So we've seen this particular figure in another video. This is just a printer cartridge. It's a rectangular prism. So we got rectangles top and bottom, and then of course we got these rectangular surfaces around the edges there. So that's what makes up what we call the lateral faces. But anyway, enough of the vocabulary. What we're going to talk about today is volume. So in other words, how much three-dimensional space this takes up. So if I had teeny, tiny little cubes, how many of them would it take to fill up the inside of this particular space? All right, so that's what we're looking at today. We're also going to look at pyramids as well, as these are the two figures in 7th grade you should have dealt with. In 8th grade, we deal with cylinders, cones, and spheres, and we did that in another video. So real quick, let's get to our formulas, and then we'll do a few quick examples, and you'll be good. So let's start with prisms, because they're the ones that are, I wouldn't say more difficult, but they're the ones that are certainly more open to interpretation, because we could have lots of different types of prisms. So here we go, prisms. And their volume can be represented a couple ways. Let's look at them. If you're talking about specifically, we'll put it in parentheses here, if you're talking about simply a rectangle or rectangular prism, then a lot of us will simply do length times width times height. All right, but again, that only works for a rectangular prism. So something that maybe looks like that when we draw it, all right, a box. However, we're going to be dealing with all kinds of prisms. So we're going to say prisms, and then this will be for all prisms. All right? So the volume formula for any prism, whether it's triangular, rectangular, whatever, is base, capital B, area of the base, times height. So let's write what those mean. So our B is equal to the area of the base, and then H is equal to the height of the prism. So let's look at a couple examples here. Let's look at a rectangular prism first, and then we'll look at something a little bit different. Oh, I don't know. How about something like this? And again, hopefully you're getting better at drawing these. Goodness knows I am. Well, maybe I spoke too soon. There we go. So if we're looking at a prism, we have 3 different dimensions, right? We've got the width, maybe we're measuring side to side. I don't know, we'll call it 8 inches. And then we've got the depth front to back. So maybe this is, I don't know, we'll call it 3 inches. And then, of course, we need a height measurement here. I don't know. Let's call that 16 inches. I don't know. We'll just make it up as we go. So if we're going to find the volume, one way to do it is if it is rectangular, and this is a rectangular prism, then we could just simply multiply all 3 together. So we'll do both formulas here for this one. So volume could equal, if we're talking about a rectangular prism, length times width times height. And again, all of those are interchangeable. If I turn the prism, suddenly this is the height. Or if I turn the prism, suddenly this is the height. So basically, we're going to take all 3 dimensions, and we're going to multiply them together. So in this case, 8 times 3 times 16. All right? And that's going to give us our final volume. So in this case, 8 times 3 times 16. Well, maybe. There we go. So it's 384 inches. And remember, we're talking about volume. So this is a 3-dimensional space we're dealing with. So it's inches cubed. All right. In other words, we're seeing how many of these teeny, tiny little 1 by 1 by 1 inch cubes we could fill up in here. And in this case, we need 384 of them. Let's look at the other formula. The other formula is going to get us the exact same answer. The only difference is this formula works for any prism that we come across, whereas this one only works for the rectangular ones. So in this case, B, remember, is area of the base. Let's do that. 8 times 3. So that is, well, actually, let's go ahead and write it out here. Base times height. So in this case, the area of our base is 8 times 3, so that is 24. And then we multiply it by our height, our height, and in this case it is 16. So in other words, if I take 24, multiply it by 16, notice we get the exact same answer, in this case 384 inches cubed. So both formulas work for rectangular prisms, but this formula works for any prism. So let's deal with that. Let's talk about any old prism. Let's try maybe a triangle. Triangular prisms are easy enough. Let's see here. Let's draw, I don't know, maybe our triangular prism looks something like this. I don't know, I'm not very good at it, but we'll see what we can do. That doesn't look so bad, kind of like a wedge of cheesecake or something. We'll draw this as a dotted line since that's that back edge we can't see. Let's see here. We know that it is 7 meters tall. This edge here is 9 meters. Let's see here. This side is also 7 meters, not exactly drawn to scale, but we'll deal with it. This side over here is 3 meters. And then notice we've got the height of our triangle, and that is going to be just 2 meters. So this is the formula we're going to use. It's the one that works for any prism. So in this case, since it's a triangular prism, we'll want to use it. So volume equals the area of the base multiplied by the height. So let's find the area of our base. So in this case, we've got 9. Notice this edge here and this edge here should be the same. Bases are the same. So I've got 9. We'll do it off to the side here. Our base is equal to 9 times the height of our triangle here. That base is 2. And then divided by 2, because that's how we find area of a triangle. Well, 9 times 2 is 18. Divided by 2 is 9. So our area of our base is 9 units squared. And we're going to multiply that by our height. And in this case, height is measured from base to base, top to bottom. So in this case, 7. And since these numbers are pretty straightforward, we won't need a calculator. 9 times 7 is 63. And in this case, meters cubed. So that would be our final answer. So it would take 63 1 meter by 1 meter by 1 meter cubes to fill this in. All right. So prisms are pretty straightforward in terms of finding area. They're certainly a lot more straightforward than, say, a cylinder or a sphere. Very, very straightforward, very simple shapes. Let's talk about pyramids. Pyramids are a lot like cones. They're very similar figures, not exactly the same, but they're similar. So let's talk about them here. We've got pyramids, and their volume formula is as follows. And I'm going to write this calculator friendly, again, just to make your life easier. So, and this will work for any. So let me put that down here. This is going to work for all pyramids. So B, area of the base, times height, divided by 3. Again, calculator friendly version. Where again, B is equal to the area of the base. H is the height of the pyramid. Oh, let's draw one. How about, let's do a rectangular pyramid. We've done sort of the easy things. Let's do a rectangular pyramid. Something that's kind of crazy looking here. So it comes up like that. Up like that. Let's get our rectangle drawn in. Of course, we got this edge here that we can't see. Something like that. That'll work. Let's see. Let's get our measurements in here. So this is going to be 4 inches on this side. Maybe, I don't know, 8 inches on that side. Now remember, we've got slant height and then we've got actual height. All right, so in this case, I'm going to measure the actual height of my pyramid. That's from the apex straight through the center to the very middle of that base. So in this case, my height here is going to be, we'll draw it over here, is going to be 6 inches. All right. So let's use our formula. We'll do it underneath, kind of ran out of room there. Volume is equal to the area of the base multiplied by our height divided by 3. So let's find the area of the base. Well, since it's a rectangle, we can just do length times width or base times height, however you want to do it. So 8 times 4 is 32, multiplied by the height of our pyramid. So again, apex to the center of the base is 6. And then, of course, we divide by 3. Well, in this case, I know 6 divided by 3 is 2. 2 times 32 is 64. So in this case, 64 inches cubed. Again, we're talking about three-dimensional space. So if I had 64 of these 1 inch by 1 inch by 1 inch cubes, that's how many it would take to fill in the pyramid. So again, pyramids work very similar to cones. Notice if you look back at your notes for your cone formula, these are almost identical. All right, we just take the area of the base, multiply by its height, and then divide by 3. So this is what we'll be working today. This is what you should have covered in your 7th grade year. And then remember, for what we cover in 8th grade are cylinders, cones, and spheres. So you now should have all of your volumes set up. You should now have all of your surface area situations set up. And again, all of the formulas will be given to you, especially on things like your state testing there at the end of the year, K-Prep, or in class. I will give you the formulas. I'm not going to necessarily tell you how to use them, but I will give them to you, and it's up to you to remember that, for example, B represents the area of the base, or that L represents the length of your rectangular prism, that kind of thing. If you've got any questions or concerns, please bring them with you to class, and we'll go over it. You guys have a great day.